What do you think, sir?
Hey Alvin, what's up?
Yeah, sir.
Nice.
You receive an email from me?
Um, I can't recall.
Yeah, about the documents that you're supposed to send the card.
Oh, yeah, I saw something from the car now. But the truth is, last weekend was a rough one. I had an activity Friday, Saturday, Sunday. So I saw the email, I have to be truthful, because the Cat Plus One students didn't even meet up
Oh,
then on Saturday. But
oh, I understood, sir. Reason being, was trying to find some questions from the other topics that you taught apart from ransom, Newton Ramson, but I'm not really finding any like those.
no
So
man,
I'm gonna get a
that's all
calculus book and see if we can.
no man, hold on. It's just two topics I've gone through.
Yes, sir. The
Okay, no, it's just said. I thought you said that other topics before Newton Ramson.
yeah, yeah, that one the can't really call the word. Like yeah,
The logarithm. Oh, that's the differentiation of the logarithmic function.
yes, sir.
Okay. No, no problem, man. You'll be fine. I'll get something to you. I'll action it today. Um, some family activity that you know I just had to give some attention to, because the other day I wasn't paying much attention because I had all these exam papers to mark, so I was really out of it. So I had to be making up. But yes,
Oh,
I will. What I want you
oh,
to do, what I want you to do, I'd much prefer if you find some past
past.
paper, yeah, and
Yeah.
work those, because
All right.
you have different okay, so like the McLarens, you have those that include the trigonometric functions, but you are not doing the trigonometric functions. So I don't want you to go and focus on an area that you're really not doing. So I would prefer if you stick to the past papers, at least you know what it is that we are testing.
Yes, sir. All right.
No problem. All right, students, did we work through that question before? Expand 2 over x plus 1 using Maclaurin series up to and including determine x to the fifth?
Don't think so, sir.
All right, do me a favor. Can we start for me, please? This is your warm-up. We need to move on from this topic nonetheless. But start for me, please. I'm giving you, no, 7 minutes past. I'm giving it 7 minutes. All right, I'll give you 8 minutes. 5:15, I'll come back. All right, guys, ready? Let me talk to me now, one, please.
Oh, sir, I haven't found the answer yet, but if you want to continue,
No, wait. I want to finish your question. So that's what I want. Let me know exactly where you are. I asked and nobody was answering. So I'm asking, how
sorry,
far are we finished?
not finished yet, sir.
All right, thank you.
Still working, sir.
Sir,
Yes, the boy.
you wanted us to put the zero where the I don't know the words to use, but you wanted us to put the zero in the f of x function, right?
Yeah.
Uh, okay. So I get zero.
Say it again.
I get, well, it's 0/1, but I get zero.
Okay. All right. For which one did you get 0/1?
So it's 0/1, so for the, it's just the f of zero. So I just put back the two over x plus one, the 2x over x plus one, and I put the zero where the x's are, and I got 0/1.
And what is 0/1?
Zero?
Yeah. You shouldn't answer me like that, you know. I saw your exam grade. You shouldn't answer me like that. You're supposed to be answering me with more confidence.
No, so
Because I know you know.
I'm confused because I'm not used
How
to
so,
this.
though, the boy?
I'm not used to this yet. I'm used to it, but if I say just come to zero, it just uh
No, that's not what I'm talking
just
about,
come
you know,
to
Papa.
x.
No, hear me out. I asked you what is 0/1, and then you gingerly said zero as if you're not sure.
No
But
man,
I'm
sir,
saying
me
to you,
sure.
I know your exam grade, and you should be answering me with more confidence.
No man, sir.
I'm going to charge you.
You charge me, sir. I still
Yes,
need to
sir.
go
I'm gonna charge
give
you.
you the food in the man, sir. But yes, sir, zero, get zero, sir.
All right. I'm seeing a message that came in about prerequisite override. Um, I did ask Lecarno to send me an email overrides and
I did, sir.
hold on now. Hold on now. Allow me to finish my thought. And he sent the overrides to me, and I completed all the overrides. Matter of fact, there were about 3 names in the email for override that was sent to me, and they were done. So those of you who are not seeing the overrides, go back and check it. If you're not seeing the override and you didn't send it to Locarno, that's your concern. I asked for it. He sent them, and I did them. So please to check. No, man, if you have passed Calculus 1, there is no need for me to do an override for Calculus 1. You can go ahead and select your course. Your grades are on the system. So once you've passed Calculus 1, there is no need for an override. Don't send me an override. Matter of fact, you can't send me an override because once you go on the system, you would recognize that you can select your course. So the grades are on the system. Once you're selected for Calculus 2, once you pass Calculus 1, you should be fine. The overrides are ready for students who did not pass Calculus 1, and then override for Calculus 2.
Sir, you hearing me?
I am.
Yes, sir. I submitted the override before the calculus grades were out because at the time when the portal was open, the grades weren't out. So I submitted it then, and that's why I'm saying that I'm not seeing calculus as yet because I submitted it from before the course grade was out. So are you saying that I must submit another one now that the courses are out, the grades are out?
Go ahead and select the course, please, sir. You should be able to see the grade there. The Calculus 1 grade is on the system now.
So I must submit another prerequisite override.
You're not understanding me. What I'm saying to you, you can go ahead and select the
Go
course.
back
The
to
system
the
is not going to give.
portal and select mathematics, calculus 2, and it's supposed to just add it to the list above.
Oh, all right.
Thank you.
Sir, can you please let me know if the answer which I sent is correct?
I'm talking and I'm muted. Yes, you are correct.
Okay, thank you, sir.
No problem.
Sir, could you kindly let me know if the second derivative is correct?
Yes, sir.
Thank you.
All right. Anybody finish your question?
Sir, on the final part of it.
Okay, the corner finish.
Same here, sir. We did the last, the x to the 5 something, and then we put it in the big formula and then get the answer, sir.
I'm taking too long on the question now, though. Is there anyone who is finished? Okay, 2 more minutes, please.
sir.
Yes, sir. Are you finished? No?
Yes, sir. I sent it to you.
I'm not seeing anything in the chat. Oh, I know why. Because the chat was open, so I'm not seeing the notification. But that's incomplete though.
You want me to put it in the 0?
Yeah. And that's not, yeah, that's incomplete. The answer is what you gave me there is correct, but that's not the form, that's not the final answer. All right. So that tells me then that you don't know how far to go down and where to stop. All right. So I think I have an indication as to where you are in terms of your understanding. How the rest of this day?
I for just do the final work, I can't find my calculator.
I'm very worried coming to class and giving you guys these warm-up questions. Every time I do it, it takes an hour out of the teaching session. I've done it with Newton Rapson, and no, I don't know why I decided to do it today. We're taking way too long to do these warm-up questions. Way too long. I can't continue because doing this because I'm gonna be running behind, and you are the ones who can complain that I didn't finish the syllabus. So I don't think I'm gonna start off with this again. But I'm happy that I did this one because I'm seeing where one student is having a difficulty. All right, it's now 5:48. I must move. And as a result of that, I'm just going to go through the question. Um, all right, so the question says, we're supposed to expand 2x over x plus 1 using Maclaurin series up to and including the term in x to the fifth. Now, I'm going to let f of x be equal to the function 2x over x plus 1. Let me just pause right here and say that some papers, when I was marking the other day for the calculus 1, was refreshing to mark. Because something like what I said just now, let f of x be equals to the stuff. And I said to you, very important to name the given function. I see some students in the exam wrote their mathematical stuff. Let this be differentiate because of this, especially when reading the stationary point question. It was so refreshing to mark. It was really refreshing to mark, as opposed to others who just bring down something on paper, and I have to be looking through the whole script in order to pick up
There's because they
sense out
tell
of
us if we
nonsense.
don't have it, you'd take off marks.
I wouldn't, because based on what based on where the rubric would have assigned mark. If the rubric says a watermark for f of 0 to be the first mark, if you don't have let this here, I wouldn't penalize you because the first mark on the rubric would have been f of 0 is 0. So you wouldn't get penalized there, but I'm just saying it was refreshing to mark the paper because I saw where students listened to what I was saying in class, and I could say that, boy, this student is truly understanding what it is that we're about for calculus 1. So if it is something that needed for you to document in order to pick up the mark, I don't have it for sure. If you can lose it. I don't want anybody to believe if the question carries 10 marks and you have the answer x equals 5 and x equals 5 is a correct mark, correct answer, that you think you get the full 10 marks. It doesn't work like that. I still go through the question to make sure that you have the correct points in order to pick up the marks. So if you just look at the question and just write the thing and then put the answer equal and expect to get full marks, you're only given marks where there's evidence of work. So your methodology is very important. Follow me?
Yes, sir.
All right. So now I'm finding f of 0. Anywhere in f of x I see x, I am putting 0. F of x is equal to 2x over x plus 1. F of 0 is going to be equal to 2 times 0 over 0 plus 1. 2 times 0 is 0. And 0 plus 1 is 1. 0 over 1 is?
0.
0.
0.
Get them away of yes, so far, sir.
So I am going to have my f of 0 right here. Then I must do the first derivative. Now it says to me, I need to go up and include the term in x to the 5th. So I have to go all the way up. Now I'm going to be differentiating. First derivative, I'm differentiating. 2x over x plus 1, I'm differentiating. The denominator, x plus 1, right here, times the differentiation of the numerator, differential of 2x is 2, see it here, minus the numerator, minus 2x, see it here, times the differentiation of the denominator. When I differentiate x plus 1, I get 1, see it right there, all over the denominator square. And then, as opposed to the question we did last class, where all of these first pieces we had to cancel because it was something times 0, because you had a constant in the numerator. In this case, you don't have a constant. So you have to multiply this 2 by this x. 2 times x is 2x, and 2 times 1 is 2. So we have 2x plus 2. Oh, I don't have the middle term. Because of space, I didn't put the middle term. And then this is minus 2x times 1, which is minus 2x. So minus 2x plus 2x is equal to 0. And I'm going to have minus 2, a positive 2 here rather. So I'm going to have 2 over x plus 1 all squared. And of course, it's going to be the denominator squared. Remember, the denominator is x plus 1. So to square the denominator, I'm going to put x plus 1 all squared. So therefore, my f dash of x is going to be equal to 2 over x plus 1 all squared. And then I am going to substitute the value of x. I'm going to substitute x for 0. Anywhere in the function I see x, I put 0. So it's going to be equal to 2 over 0 plus 1, which is 1. So 2 over 1 is equal to 2. I heard a few students sent me private messages that I responded to. Is there anyone in class that still don't understand up to the point where I got the f of 0 to be 0 and f dash of 0 to be 2?
No, sir.
Oh, okay, good. And then now, remember, we had a robust conversation last class, and I said to you, it is important that we simplify our differential, because the differential again is going to be used for the other differential. Meaning, if I have the first differential, it's best that I simplify the first differential, because if I don't, I'm going to have a challenge because I'm not going to have anything to work with. Understood? Yes, no, maybe so.
Yes, sir.
All right. So now we're going to differentiate. We're finding the second derivative and we're using this one, the simplified version. The denominator, x plus 1 all squared, see here? The denominator, x plus 1 all squared. Times the differentiation of the numerator, a constant. See, I got the 0 here now. Minus the numerator, minus 2. Times the differentiation of the denominator. Differentiating the denominator is a power rule. So it's going to be 2 x plus 1 raised to the first power times the differential of the inside of the parenthesis, which is going to be 1. All of this goes to 0. So I'm just going to be having negative 2 times 2 times x plus 1. The x plus 1s cancel, so I have 3 of them left. And negative 2 times 2 is negative 4. So I'm going to have negative 4 over x plus 1 all squared. And then, when I substitute, and where in the function I see x, I put 0. 0 plus 1 again is 1. And negative 4 divided by 1 is going to be negative 4. Are you with me so far?
Yes, sir. Get them there, sir.
All right, good. And then now I got negative 12. I'm not going to go through any more of the differentiation. I got negative 12 and I got negative 48. The more what you sent me was this, with the 0 right here. And that is
Never
correct.
completed.
It's never
By putting
right.
the
Right. So it is correct, but it wasn't completed. Follow me?
yes, sir.
Good job. And then now is where some of you are having a challenge. Oh, I went to the fifth derivative now. Negative 240. Got that?
Get positive 240, sir.
Look at mine and tell me if you agree with my negative 240.
Yes, sir.
Sorry, it's positive 240.
That's what I'm saying, sir.
Yeah, positive 240. Jesus, my eye them get dark. I need to get some water. All right, cool. Yeah, it's positive 240. You know, I was going to say, but this is negative 48. And I see the pattern, plus, minus, plus, minus, plus. Yeah, so yeah. Good job. All right, now you see the formula in pink? That's the formula. Now I need to substitute. It's my f of 0, f dash of 0, f double dash of 0, and so forth and so on. Now becomes important. And this is where I'm going to put my f of 0, my f dash of 0, my f double dash of 0, my f triple dash of 0, so forth and so on. That's why those are important for us to calculate up top. Yes, no, maybe so. Guys, talk to me now, man.
So repeat
Yes,
what you
sir.
said.
I'm asking if you are if I'm correct right there.
Yes, sir.
Yes, sir.
All right, good. So I'm
Sir,
making this up. Go ahead.
no question. I'm not sure if you had clarified, but when you said going up to x to the fifth, should we be looking in the denominator or should we be going up to the fifth derivative?
No, we're looking for the term in x to the fifth. So this term here, you recognize when I expand x plus 1, hold on. X plus 1 is a term that is up up to the fifth. It's not the fifth derivative, because this fifth derivative here really give me x to the sixth. Let me just check something here. The first derivative give me x squared. The second derivative give me x to the third. The third derivative give me x to the fourth. The fourth derivative give me x to the fifth. Positive 12 is the third derivative, so it's positive 12x cubed. Right, positive 12x cubed and negative 48x to the. Anybody feel that? Why I feel like I just felt earthquake a while ago.
Oh, sir, enough, sir.
No, sir.
Me alone have work because my yard, you know.
Sir,
All right.
where are you?
Constant Spring. Constant,
Oh,
yeah, Kingston.
no, sir. No.
All right. I made a mistake somewhere. I'm trying to find my error. I made a mistake somewhere with this question, guys.
Should have, sorry, we should have moved on from
You
the
probably,
negative
yeah.
48.
I'll come in.
So it's probably say you need to have, but the question should have like x to the 6. Not x to the 6. This,
I'm wondering if
yeah.
I did this one or if there's a password question or something not correct. Let me just check that quick check.
Sir, me have a different answer from your screen still, but I think that my side wrong.
No man, hold on, I'm coming. Give me half a second. That is correct. And then that cancels. Um 2x. 2x cancels 2x and then we have 2 plus. No, it's going to be 2, right? So it's going to be 2 over, right? So that is going to give me, the first derivative gives me square, the second derivative gives me a cube, the third derivative gives me to the fourth, the fourth derivative gives me to the fifth. But why do I have negative 48 over to the, so this is going to be f of 0 is 0, f dash of x is positive 2, f double dash of x is negative 4, f double dash is going to be a negative 4 over 2 factorial, f triple dash is positive 12 over 3 factorial, positive 12 over 3 factorial, and then it's going to be the fourth derivative is x to the fourth over 4 factorial, and the fifth derivative is going to give me, oh yeah. It's, no, the wording of the calculation is correct, the wording is incorrect. Up to, yeah, it's correct, it's correct. It is a fifth derivative that is going to give me, yeah. So this is supposed to be x to the sixth. It's a wording that is incorrect. The term of in x to the sixth. Sorry, say it again. The calculations are
We have a
correct.
feeling. We have a
I stopped
feeling.
at negative 48.
Yeah,
Right,
because
right,
it's the
right,
50, see.
right. So
That's
the
what I said.
wording, the calculations are correct, is the wording of the question is incorrect. You follow what I'm saying?
No, sir.
Yes,
Yes,
sir.
sir.
The wording is, the calculation is correct. It's the wording of the question
No, it's
that
just
is
the
incorrect.
question. The way the question I asked for is
No.
incorrect.
The question is correct. The question is correct up to this part here.
Oh,
Up to this part, x to the fifth. You follow what I'm saying?
yes, sir.
Right. It's up to this part. So it's supposed to be x to the sixth. Yeah. But the calculations are correct. Thanks for pointing that out, Rayton. So the calculations are correct. It's just a term that is incorrect. And I think I was the one who made up this question, and then I could have copied something from something and didn't change this piece here. So I need to, no, sorry, that's not what I meant to do. I need to amend that piece. All right. And then now we are going to go through the calculations and evaluate your 4 over 2 factorial, your 12 divided by 3 factorial. Your calculators can do this in one shot. And your 48 or negative 48 over 4 factorial, so forth and so on. And then you'll end up with what is here in red. Follow me?
Yes, sir.
Sir.
Get all of them, sir. Just becoming a calculator for the last part.
Right. All right. So let me ask now. So how are we feeling with McLaren's?
Solid, sir.
All right. Did I give you one with Ellen in it at all when we were practicing?
Yes, sir.
LN? Yes, sir.
I
Sir,
did.
the
Okay.
Last class, sir. And sir, you never send the.
I know. I saw your email. I was able to action one. I don't know if Kyle touched back base with you, but I was saying to Alwyn earlier, this weekend was really for family. I mean, I have been doing quite a bit in terms of marking the exam paper, and I had some family stuff to take care of. So I was very limiting email response. I saw your email action the override request, and I saw the one read the calculus one. Kyle messaged me and I asked him to touch base with you for something. So yes, I will definitely get these off. I just had some competing stuff that I needed to just sort out. All right. Hope that answers your concern. I was going to ask you a question though. You said that I did one with the Ellen last class. How was that one for you? You think you're okay with that?
Well, yes, sir.
Yes, sir. Remember, for me, the first part they missed me up whenever something to find a differentiation for the things in the parentheses. So that they choke me.
All right. I'm afraid to give you another one to do because it's going to take up the other hour, and I don't want that to happen. I'm at the end of McLaren's, but I'm feeling that there is something else that I need to do with you.
Mr. Shan?
Yes, sir.
Yes, good evening. I just want to let you know that I have not been as present as I should recently due to matters on my control at this point. My intention, however, is to catch up using the videos. I haven't seen anything. Have you posted anything and I'm just not able to see them?
Did you hear my discourse just now with Lakanu?
I didn't. I didn't.
Okay, all right. Yeah, so I just responded to him. So no, nothing was done over this weekend. Yeah, so they will be done. Okay. I don't want to repeat myself. Yeah. So when you listen to this video, you'll get the explanation as to why. I just give the class an explanation as to.
No problem at all,
right.
Sir.
But you will get them. You know you'll get them, and I'm going to sort them out for this in a couple of hours from now.
Okay, sir. Thank you.
No problem. All right. So I see another question. I think this one is a past paper on McLaren's, but I may give you that as homework. I'm not going to run the risk of you taking that enormous time to do the question. At least for me to introduce something.
Yes, sir. Give us our homework and move on to the next topic.
Oh yeah, that's what I'm doing, sir. Without any apologies, that's what I'm doing. If only the document would open. All right, it's now open. All right, so I'm going to be looking at some applications now to integration. And I think in the interest of time and for me to be a little bit more purposeful, I want to start, not there, but I want to start at the trapezoidal rule. I'll come back with that one. Let me share my screen, please.
Yes, sir.
All right. I'm going to ask, listen to what is going to happen now. It's now 12 minutes past. This is not a difficult topic. I am going to be starting and finishing this topic in class tonight. And all I'm going to be doing is going through maybe one or two, and then I give you a question or two for your homework. It's not difficult. What I want you to do, though, is to take about 3 minutes to read these 4 lines and try and understand what it is that I'll give you a little bit more than 4 lines. I think I want to give you up to here. Upper limit and lower limit. Just read that for me, please. Take your time and read it. I will explain it. You don't have to worry about it. I want you to read it first. What I'm trying to do in class is to develop your ability to read the mathematics and understand it. I want you to do that, and then I will come in and do some explanation for you. I'll give you 3 minutes or so. Starting now. All right. Did anybody understand anything that they read at all, or is just one blur?
A blur and a half.
A
All
blur and
right,
a half.
so to me, this
Mhm.
looks like the opposite of what we just do a while ago in McLaren series.
Okay.
Yeah, and so guys, this has a f of x subscript n.
Mm-hmm. Okay.
Yes, sir. It looked like McLaren series, but instead of differential, it's integral.
Okay. All right. I know why both of you saying that. Anybody else? I didn't have any. Go ahead.
So the bottom part, the Vx equal B minus A over N. I
Mm-hmm.
think I understand that part, but I don't really understand anything else.
All right, no problem. All right. So thanks for trying to understand. I think I can see where you guys are saying that it looks like McLaren's, because this is really integration, application to integration, and integration is a reverse of differentiation. So I won't tell you that it is exactly opposite to McLaren's, but I can see where you guys are thinking outside the box, because what this topic is on, this is now our second unit. That is, the first unit was applications to differentiation. This unit now is looking at applications to integration, and I'm looking at the trapezoidal rule. There are several different rules. I think
Sir, this is something else. When you first say that they through the whole formula, the 2 times the function are always constant or
very good, sir. But where do you see the tools?
For the f of x.
after in the close, they call it L brace after the first function. All right, but I said that is the derivative, the second derivative. Continue, start from the second derivative of the function.
And
Continue down third, fourth, fifth, sixth.
and talk to me now, man, Alvin. You're seeing something, and I'm happy that you're seeing something, but you see something, but you see only with one eye. Look with the 2 eye, them, no, man. And tell me you see again, man. You see something else, man. And the rest of you seen it too, but you're not explaining yourself. Come, talk to me again. So hold on. So you're saying that you recognize something with the tools. Excellent. And I'm going to explain that. I know some of you don't like my explanation with my graphic stuff, but the class agreed that it worked last semester, and I'm going to do something this semester again now with something that I'm going to concretize it.
This is something else, sir.
Mm-hmm.
From x subscript 1 to 3, that is implementing, and after the continuation, we see xn minus 1.
Mm-hmm.
Yeah.
That's just the last term.
Oh.
That's just a term after the last term, actually. So yeah, but and at that moment I open my eye and say, man, anybody has seen it? Because Alwyn came up with something that I'm happy that he started the conversation, but there's something else.
I did do something last semester, but I'm not sure if I the same one. Is
So, sir, say that means that the 2 is B, which is the upper limit, and the subscript will be the A, which is lower limit.
Well, yeah, that is correct, but you got into something else. You started the conversation now with the tools, and I love that conversation, and I want us to expound on that a little bit more. You gone to the upper limit and the lower limit and I don't know if that's what Lacana was saying before you cut him off. But yes, Lacana, if that's what you're saying, yeah, man, we did something like that last semester, but that's not what I'm talking about. Alvin, you raised something, and I want us to ventilate that a little bit more. You said that you recognize something with the tools. The rest of you, look at it for me, please, and tell me what it is that you see with the tools.
Sorry, you're saying to the n minus 1 is the upper limit?
No, that's not what I'm saying.
Oh,
So,
no.
okay,
So
so,
the,
alright,
the tools are
go
constant
ahead.
and recurring.
So what's x to the n, sir?
All right. Don't focus on that just yet. The rate on. Let us. I can't tell you, but I don't want to tell you. I want some discovery learning tonight. All right. So let me see if I can focus the conversation somewhere. The conversation is Alwyn said, "Oh, sir, I recognize something." What, Alwyn? Missing something with tools. I said, "Good." Sir, and the tools them is in the square bracket. Never really call it the square bracket, but that's what he meant. The tools are in the square bracket, and I'm saying there is something specific, something that you're seeing with the tools. What are you seeing? Look at it. Look at. I'm directing the conversation now in the square bracket. Yeah.
Sir, the tools there, in between the first and the last.
Thank you. Thank you, Tariq. Alwyn, are you seeing that?
Sir, I never really hear what you said clearly.
Repeat, Tariq.
The tools stay in between the first and the last. So you're just writing in the middle of the first and the last one. Yeah.
Oh.
You see that, Alwyn?
Yes, sir.
All right. Everybody see that?
Yes, sir.
And I even color code it. I color code it because I want you to see it. The one in blue, the ones in blue don't have no two. Talk truth.
Yes, sir.
Yes,
Yeah.
sir.
But everything else have two. All right, let me go back to your question, Rayton. You're asking what is the x minus 1 term? So normally in math, x to the n is representing the last term. X to the n is representing the last term. So this is actually representing the last term, x to the n. Xn, x subscript n is the last term. So s subscript n minus 1 is representing what kind of term now?
Second to last term, sir.
Very good. Very good. And x subscript n minus 2 is representing the?
Sorry, repeat, sir.
X subscript n minus 2 is representing the?
The term second to last term.
The third to last term, right. The third to last term. Good. Everybody see that?
Yes, sir.
Yes, sir.
Right. Great. Okay, fabulous. So yes, very good observation, even though you never ventilated fully for me, Alwyn. But yes, you started a conversation and somebody saw it and finished it off. Yeah. So the tools them go around everybody away from the first one and the last one. Why, sir? Nobody now ask me.
Why, sir?
All right, good. Thanks, Alwyn. Soon come to you. So let us look at the first part because we're going to do an activity now, and I guarantee you, after we do this activity, if you can't understand this, something wrong. You either never had enough lunch or no lunch at all. Let's go. The trapezoidal rule. This technique is a much more accurate way to approximate area beneath a curve. Area beneath a curve. To construct the trapezoids, you mark the height of the function at the beginning and the end of the width interval. See here? The width interval, somebody was mentioning B, A. So the width interval, you're measuring something here. So from Yasso, go all the way down to Yasso. All right? And then connect 2 points. However, the method is going to require you memorizing a formula. As I said to you at the start of Calculus 2 is not to be taken lightly. Everything that we do, we have formulation. Every topic we do, we have a different formulation. Also, I don't have to worry because I'm going to get the formulas in the exam wrong. So you must know your formulation. And then it says, no, let f be a continuous or be continuous on AB, the interval AB. And then the trapezoidal rule for approximating the function f of x dx is going to be given by that ugly looking formula. Now, it speaks about the width of the formula. It says at the beginning and end of the width interval, we need to know how to calculate the width. The width of the function of the trapezoid is going to be calculated by using Vx, b minus a over n, the number of trapezoids that you want. The number of trapezoids you want. Let me ask you a question. If you have a clump of sugar, and you drop that clump of sugar in a cup of water, and you try to mix it out, but you have some grains, some crystals of sugar that are not clumped together. The crystals are individual, and you put those and you mix it out. Which one to mix out faster?
The individual crystal of sugar.
Anybody have a reason for that? You're correct. It can give me a reason why that happens.
Sorry, it's smaller and you have a less density than the clump.
Excellent word. It's smaller. Excellent. So the smaller the trapezoid is, the more accurate your calculation or your approximation is going to be, right? So in chemistry, we talk about things like surface area increases the rate of a reaction. So the more surface area you have, it's easier to dissolve. When you clump it, the rate of dissolution is going to be or dissolving is going to be greater, right? When you increase the surface area, it moves quicker and faster. So the more you increase the trapezoid, the more trapezoids you use, is the better for you. All right. Other thing is, Alwyn, since we started the conversation, Alwyn lives in the country and his father has lots of land. But the land that his father has, the topography of it is very difficult for him to see, but he knows where the boundary lines are. See the boundary lines here? Upper limit, lower limit. See here? These are the boundary lines. Him can't encroach on the boundary line, because if he does, him neighbors can call a popo upon him. All right? He can calculate the area under the curve. He can calculate the area under there. So him can say, yo, here's the plan. You know, so one developer come to me and say, if I now sell a plot of land, and the developer say, yo, you know me buy the plot of land in a month. Me can give you, if you give me the land, I'm gonna build it up for you. Me can give you 2 of the apartments, you know, and this, incidentally, this is what people are doing now. They have land, they don't have the money to do it. They invite the developers to come in and say, yo, let us negotiate. It's either the developer is going to buy a property and give to them to live in, and the barter, the exchange for the land that they own. So they may sign over the land that they own, and the developer will say, I'll put you where you want. You want a house or you want an apartment? And the developer will buy a nice apartment, because them can afford $50 million, because to pay $50 million for a piece of land is nothing to them. You know why? Because by the time them done build up and sell that at $200 million, they might get for the properties, right? Because an apartment now, easy, is selling for 24 million, 25, $30 million, right? And if you're selling an apartment for $30 million and there are 10 units in the apartment complex, that's 300 million. So if I am going to buy a house for you for 50 million, but when I finish selling the property, I'm going to get 300, which is more, 300 or 50?
300.
Yeah, man. So by the time you talk about the 50 million when we spend for you, at 250 million that I make. So you have a piece of land, Albion, and you say, yo, Sir Sean, I have a problem, you know. Me I get a piece of land. Yeah, but me nobody want to live right here, say no more, come to Kingston. Not a problem. I can go find a piece of land for you, and not a piece of land, a nice property for you, where you can get a 6-bedroom. I'm gonna buy that cash. You don't have to pay no money out of your pocket. And you come out of the property we have, and the developer will get to develop it. And when you finish now, you can say, blow, this the man get out of it, or there's another conversation. The man may say, say, me now move over to the area now. I'm saying, don't worry about it, man. I can give you one of the penthouses because I'm gonna have 4 penthouses. So you give me the plot of land and you get a 4-bedroom penthouse. You see, so that sounds good because me the one develop this and me can't develop it and me go get a penthouse. We're doing take the something. The man is going to say the topography is not so good, so you have to go blast it and calculating the area under the curve. And the man will go see how far down him can go in the plot of land, how many stories him can build. Because the more stories the man can build on this plot of land is more money for him. And what's like when I'm going to give away one of the penthouses, and you can even negotiate to say, yo, the penthouse have to be furnished, you know. And you make your terms and don't come to an agreement. That's exactly what is happening. Look here. It went further. No, before me read it. See the plot of land there. So this is a topography, which is a function really, right? But the man said, you know what? Jada, up here are too hilly, you know. And the man said, no, man, you know, say you can blast it and go down there, say no. And when this shaded area I'm talking about, and you use this as a baseline. Oh, but hold on there now. That means if we use trapezoidal approximation, we can find out how much area on the right here. So, and the man said, but you don't know what can happen. We can have one basement apartment. We can have underground parking. We can have this. We can have that. We can put in a well underneath it so that we know people not have to run out of water because they all have water stored in the place. And we can go 3, 4, 5 stories up because if we go all the way down here, it's a bedrock. Yeah, man, good piece of land. Watch me. How many trapezoids are you seeing here, if you know what a trapezoid is?
Three.
3 trapezoids, very good. You have one right here, you have one right here, and you have one right here. All right, watch me now. So this is my function that goes all the way up and all the way up and so forth and so on. So it's wavy. Here, I'm connecting, and by the way, incidentally, between A and X1 is the same distance or width as X1 and X2. The same distance or width as X2 to B. You notice I set up here the width interval, and here I'm using Vx is B minus A over N. N is the number of trapezoids. So I know how many trapezoids I need. So based on what I'm going to be doing, the trapezoids will have to be equidistant. It has to be equidistant. Now, what was happening? It says the area of any of the trapezoid is half the sum of the parallel sides times the perpendicular height. You should know this from high school. See it here, so? The area of a trapezoid is half the sum of the parallel sides, A plus B, times the perpendicular height, H. Now, I will explain these two things here. These 2 lines, we're going to explain it now. I want you to put up your right hand in front of your face. Don't cover your face with it now, but put your right hand in front of your face now for me, please. It works with the left hand also, you know, so whichever hand you want, you feel comfortable. And then, of course, if you put up your right hand, you're going to have 4 fingers on your thumb. I don't want you to spread your thumb all the way out. I want you to bring your thumb close to the index finger. Let me know if you're following my instructions.
Yes, sir.
Good. I don't want your fingers to be kissing each other. Put a little space between all of them, including the thumb. The space between your thumb and your index finger. Still following?
Yes, sir.
How many fingers do you have up?
Sir, 5.
Good. Excellent. And I only assume just know that all of you have all your fingers, all right? So that's why I asked the question, how many fingers are seen? If anybody said 4, I would have said you're not qualified. In a nice way. So good, you're seeing 5 fingers. How many spaces can you count between fingers?
Sir, 4.
Excellent. Excellent. Is everybody with me so far?
Yes, sir.
All right.
Yes, sir.
Work
Yes,
with me.
sir.
Work with me. Work with me now. Work with me. Work with me now. Work with me. Work with me. So therefore, the spaces between your fingers are going to be called your trapezoids. How many spaces between the fingers again?
Sir, 4.
Good. And your fingers are going to be your ordinals. How many ordinals you have now then?
5.
Good. So you're going to have one more ordinal than trapezoid. True or false?
True.
True.
All right. I'm only hearing one or two people answer me now. But if you don't want to follow me, this is your funeral. Work with me. So, all right. So you're not seeing it in that example. When I give you the actual example, you'll see what I'm talking about. All right. Okay, so let me show it from here. So I am seeing A and B. B is my upper limit. Can you all see that? That B is my upper limit
Yes, sir.
Yes,
and
sir.
A is my lower limit. Great. All right, work with me now. So let me finish off with the fingers.
Quick question now before I proceed. Is it your lower limit because that's where the curve starts going downwards, or
No, man. The lower limit because no. The lower limit because it's closer to 0.
okay?
The smaller number is a lower limit and the bigger number is the upper limit. So this A is the lower limit because it's closer to 0, and the B are the upper limit because it's closer to it's bigger than 0. It's going away from 0. So it's the upper limit here is a smaller y value than the upper limit. It has nothing to do with the curve. It's just that this is away from 0 and this is closer to 0. So the upper limit is going, and why it's called the upper limit? Because it's bigger than the lower limit.
Okay, sir.
All right, good. All right, so let's go back to the hand now.
Distance will be a better example then.
Yeah. Same difference. All right, so let's go back to the hand now. So put up the hand in front of your face. How many trapezoids are you seeing?
4.
4. The trapezoids are the spaces between fingers. How many ordinals are you seeing?
5.
5.
Good. So if I have 6 trapezoids, how many ordinals do I have?
7.
Repeat, sir.
7, sir.
7, sir.
All right, very good. Then why you for listening, you know. If I have 8 trapezoid, how many ordinals I have?
9.
9.
Good
9.
job. If I have 99 trapezoids, how many ordinals I have?
100.
100.
So you see what I just did a while ago, you know. I just did an example. I just did an exercise a while ago, and that is the last exercise I'm doing on that. So when you go into the exam, and if they said to you that it has X number of trapezoids, or if the question says it has ordinals, remember the number of trapezoids is going to be 1 less than the number of ordinals. If I have 4 ordinals, 4 trapezoids, sorry, 1, 2, 3, 4, like the hand that is above, you look at it and say that you have 5 fingers. So that means you have 1 more ordinal. I give you that example so that when you go into the exam and you forget it, you can put up the hand in front of your face and you can't say you cheat as long as you don't have nothing written in your hand. And you look on it and you start to beat the man. I'm supposed to say, no, man, why everybody are looking at them handmiggle? Come, no writing, look looking at handmiggle. And the man said the handmiggle empty, but you just went to be doing the stuff because teacher is showing you something. The spaces between your fingers are called your trapezoids. So I'm going to have 1, 2, 3, 4, and my fingers will be my ordinals. So I'm going to have 5 ordinals, but I'm going to have 4 trapezoids. All right, work with me. I want to finish off this hand signal before I move back to the diagram. Work with me. So when you look at the distance between your thumb and your index finger, your thumb is touching how many sides of the trapezoid?
Sir, 1.
1 side.
Everybody see that?
Yes, sir.
Very good. Excellent. Let me repeat because I know somebody don't know what we're talking about. When you look at the trapezoid between your index finger and your thumb, Your thumb is touching how many sides of the trapezoid?
One.
One.
Sir.
Yo.
If I can put up, turn on the camera, sir, and use your probably
No, guess what? No, man. You have, Kenneth, you have to go work with me. That. Put up your hand, Kenneth. Put up your hand, Kenneth. Put up your hand in front of you. All right?
But
all right. But
just
you,
one
you,
side,
you, you not see because you cover your eye them. Put it away. Put, all right, work with me now.
Yep.
How many fingers you have up, Kenneth?
5.
Good. Don't allow your fingers to kiss. Put some space between them.
All fingers, right?
All fingers, yeah. Including the
Right,
thumb
sir.
and the index. How many spaces do you have between your fingers?
4.
Good. Those are your trapezoids. Between your
Yes,
fingers
sir.
are your trapezoids. So you have 4 trapezoids. How many ordinals do you have?
5.
Good. You will have 5 because the ordinals are your fingers. So the trapezoids are the distance between and the spaces between your fingers. All right. What I'm saying to you now is what I'm saying to you now is when you look at the trapezoid that is between your thumb and your index finger, your thumb is touching how many sides of the trapezoid?
Oh, I understand now. Okay.
Right. Everybody catch that? 1. All right. Work with me now. Between your index finger and your middle finger, that trapezoid is touching how many sides? Your index finger is touching how many sides of that trapezoid?
Sir, 2 sides.
2? You agree?
2 sides, sir.
Yes, sir.
Between your middle and your ring finger, how many sides of the trapezoid touching?
2
sides still.
1, sir.
2 sides still, sir.
Alwyn.
Yes, sir.
To God, no.
Sir, yes, sir, between the ring finger and the middle finger.
Yeah.
Yes, sir.
How many trapezoid are touching? How many sides in your how many trapezoids your middle finger touching?
Oh, sir, one trapezoid and 2 ordinals, so 2.
2, good. Your ring finger is touching how many sides of the trapezoid?
2.
Good. Everybody seen that?
Yes, sir.
Your pinky winky is touching how many sides of the trapezoid?
So just 1.
1, sir.
Alvin, you see that?
Yes, sir.
You
That
know,
was
see
my
it,
honest mistake.
You see it, Alvin?
Yes, sir.
All right, watch me now. That explains why I have this 2 right here, so, and this 2 right here, so, and this 2 everywhere else in the middle, away from the thumb. The thumb is touching only 1 trapezoid, and the pinky winky is touching only 1 trapezoid. So therefore, I now have no 2 right here, so, and I now have no 2 right here, so. But any number of terms inside here, so, I have 2. Then, sir, on a 5 finger, I have fine. What if I put both hands together? And then now I say we have many more trapezoids. Are you seeing this explanation why it is that I don't have a 2 at the first one and a 2 at the last one?
Yes, sir.
All right, watch it now. The reason you see all those 2s in the trapezoid is that every base is twice for the consecutive trapezoid except the bases at the end points. My thumb now touch 2 of the trapezoid. It will only touch 1 side of the trapezoid. Which side is it touching? The side between it and the index finger. Talk truth.
Yes, sir.
Good. And then the pinky winky is touching only 1 side of the trapezoid that is between the ring finger and the pinky winky, don't it?
Yes, it is.
But the ring finger, the middle finger, and the index finger are touching both sides of the trapezoid, don't?
Yes, they are.
Anyhow, me you not question on this, and you not catch this. Remember, say you not go pay me.
Oh, sir, it's too easy.
All right, because I'm telling that's what I tell you now. My way of teaching is different from somebody else. I don't think nobody else would have come with something like this. But you have to find ways to study and to make the thing come alive. You go into the exam and you forget, put your hand in front of your face. Now cover your eye them because you're not going to see it. The trapezoids exist between your index, between your fingers. Your ordinals are your fingers. So that alone will tell you that you're going to have 1 more ordinal than you do their trapezoid. Remember also for the formulation, why it is that you have the two them inner everything away from the last ones them, the first and the last one, is because the pinky winky and your thumb is only touching one side. The base of it is touching on one side of the trapezoid, but every other finger is touching two sides of the trapezoid. So which is why it's going to be times 2. All right? Good. Now, watch me. There are times you're going to overestimate and you're going to underestimate. And even if I don't do a question tonight, I'm fine. As long as you can understand pictorially and represent what it is that I'm saying, mentally, I am good to go. You know, sometimes when I go to the supermarket and I know I don't have enough money, I mean, I want to go to the cashier and she share me. What I do is, if I pick up a loaf of bread and the bread is $550, I call it $600. If I pick up a tin of milk and it's $300, me just say, all right, it's $300. So 6 and 3, 9. And I pick up something for $150, I go call it 200 and say 9 and 2, 11. Right? And I say, all right, what else we can buy? I say, you know what? 1100. And I go multiply that by 15%. I go say, I can't buy that 15%, you know. I go to 20%. So $1,100 at 10% is going to be $110. And I times that by 2, $220. 220 plus 11, I got to get $1,320. Blow me at $1,500. I can confidently walk to the cashier and know that my bill will not pass $1,500. What I did was to overestimate. So I can go to the cashier confidently, and this is what I do every day. When you do, you overestimate, so you know what it is that you have. Watch this. I am estimating. You know, so right here, so there's a big gap right here, so because the trapezoid, me can't draw the trapezoid any better than this. So right here, so I'm going to have an underestimation right here. So note, the trapezoidal rule overestimates a curve that concaves up. See here, this one concaves up, and it underestimates a curve that concave down. See here, this piece concave down, and it underestimates because we ain't have a piece of it over here. So talk truth.
Yes, sir.
Good. You also have another piece over here, so don't.
Yes, sir.
So what it is saying, the trapezoidal rule is saying, you see, when I have the underestimation right here, so the overestimation will no, that's not the word, will compensate for the underestimation. Let me say that again. The underestimation right here, so the overestimation will, what the word? Compensate for it. That's what the rule is saying. So it says the area of the trapezoidal and the shaded region is going to be approximately equal to this. Now, let me explain what this is. This is a question. You're integrating, but you're using the trapezoidal rule, which is an approximation. You're going to have Vx over 2. Sir, what is Vx again? Vx is going to tell me the width of the trapezoid. It's going to be B minus A over N, the number of trapezoids that we have. See here, Vx is B minus A over N, the number of trapezoids. So that is going to be equal to that. So in this case, in this example here, we have the 3 something here. Sir, 3. Watch this now, guys. Look. Left the chicken alone and look on the one here. How many trapezoids you seeing right here, so?
Sir, 3.
Good. How many ordinals it have?
4.
All right, work with me. 1 ordinal, 2 ordinals, 3 ordinals, 4 ordinals. You're going to have 4 of them. Between the 2 ordinals, we can have a trapezoid. Talk truth.
Yes, sir.
Yes, sir.
Plus sign is my trapezoid, 1 plus sign, and x plus sign 2, and x plus sign 3. Want to see it?
Yes, sir.
Oh, yes, sir.
You put up your 4 fingers. You hide your thumb, put up your 4 fingers. This is your index, this is your middle, this is your ring, this is your pinky winky. Your index now is only touching one side of the trapezoid. Talk truth.
True.
So there's no times 2 right here. So your pinky winky is only touching one of it, don't it?
Yes, it is.
There's no times 2 here. So only them 2 here are touch 2 sides of the trapezoid. That's why I have 2 right here, so, and 2 right here, so. Easy, easy. You can't go wrong with this. So may I explain to you, you know. Right? So this is how we're going to set up our formula. So right here and then, no, you should know how to set up a formula. The man them hear the question, the man them say, yo, we have this amount of ordinals. If you have that amount of ordinals, you write down the number of ordinals. If them say this is amount of trapezoid, you're going to write down one more term because the ordinal is going to be one more term than you have your trapezoids. All right? Sir. You write it out, you set it out, and when you set it out, all you can do is put Vx over 2. So where Vx again be is the width of the trapezoid, because remember the trapezoid must be equidistant. Must be equidistant. So in order for you to calculate the actual distance or the equal distance between them, it's going to be Vx. Vx is b minus a, the upper minus the lower limit, divided by the number of trapezoids. All right? I have 7 minutes. I am going to just work through this one with you. I can do this in 5 minutes because you understand this. Can do it in 5 minutes. Work with me, guys. Just give me your undivided attention here now, please. It says use the trapezoidal rule to estimate. Upper limit is 2, the lower limit is -1. All right. X squared minus 3 dx and n equals 3. But n is the number of trapezoids, sir. Okay. So it has how many trapezoids?
3 trapezoids.
How many ordinals?
4. That means you have 4.
4 ordinals.
4 ordinals. Good job. Work with me now. Which is the first ordinal? We're starting off with the lower limit. Which is the first ordinal?
0.
So
-1.
Negative
Oh,
one.
After -1 come what? I want you to count with me now. -1 is the first one. After -1 is?
0.
0. That's 2. After 0 is?
3.
1.
1. So after 1 is?
2.
How many numbers you get right there? So come again.
Four.
-1 is the first one. Then 0, that's 2. Then 1 is 3.
4.
Then 2 is?
4.
So do you expect to get those 4? You expected to get 4 ordinals, don't it?
Yes, sir.
Yes, sir.
And the n is
Yes, sir.
3. You can't go wrong, you know. All right, continuing. Now, so this is my formulation. I expect to get 4 ordinals because it says n is equals to 3. But in my head space, we don't work it out already. -1, 0, 1, and 2. This is my end point, and this is my starting point. So you can't start at any other number than -1. You must start at -1. And you can't go further than 2, because you go further than 2, a smother yard gone, you know. Don't follow all the way in. So you have to stop at 2. All right, watch me now. It says Vx over 2. Vx, in order to get the width of the trapezoid, is going to be b minus a over the number of trapezoid. B minus a, up here, so b is the upper one. So 2 minus -1 is how much?
1.
Really?
So 2 minus 1.
3, sir.
3. 2 minus -1, Alvin.
Oh, yes, sir.
3. Good.
Yes, sir. But you just said 2 minus 1. You know,
No, man, I said
minus.
2 I said 2 minus -1.
Oh, I never hear, sir.
Okay. So 2 minus -1 is 3. And what is 3 divided by 3?
0. 1.
Alvin.
1.
Sure. So 3 divided by 3 is 1. But we don't figure that out a long time, you know. You know why? Because -1, then 0, then 1, then 2. And so come we're going to get the 4 ordinals. And so we're going to get the 4 ordinals. Well, we didn't figure out a long time. So this is it. 2 minus -1 is 3 equals 1. So that tells me the width of the trapezoid. That tells me the width of the trapezoid. My ordinals, therefore, are -1, 0, 1, and 2. We figured out this long time before them. Long time before them do it. Watch me now. All I'm going to do is to recall the function x cubed minus 3. All of you know how to put it in and take it out. So I am putting in the number, -1, and I'm taking out the response. Input, output. Input, output. You put it in, you take it out. Watch me. Into the function x squared minus 3, you're putting in -1, you're taking it out. -1 squares is +1. +1 minus 3 is -2. You put it in, you take it out. You put it in, you take it out. You substitute it into the function, and you're taking out the result. That one they're done. You move to the next ordinal. You put it in, you take it out. Anywhere in the function I see x, I am putting 0. 0 squared minus 3, you put it in, what do you get out? -3. Moving on next. Anywhere in the function I see x, I'm putting in 1. You put it in, you take it out. 1 squares is 1 minus 3 is -2. You put it in, you take it out. The next one is going to be 2. Anywhere in the function you see x, you put in 2. You put it in, you take it out. I am putting in the 2. 2 squares is 4 minus 3 is 1. All I'm doing is putting it in and take it out. You're putting it in, you take it out. All right? And all I'm going to be doing thereafter, guys, you already set up this formulation right up here, so. You set up the formulation right up here, so. All you need to do is, all you need to do is just substitute. Just substitute. That's all you need to do is to substitute. Watch me, because you have the formulation up here. You know what your V of x is. Your V of x is 1, because that's the width of the trapezoid. So you can have 1 over 2. Watch your secret. See it here? 1 over 2. The -2 is the first one. Remember, the first one and the last one are not affected by the ×2, but every other term is. Look, the first one -2, you write it back. The second one is going to be 2 times -3. The other one is going to be 2 times -2, but the last one is no ×2. It's just it alone. Work with me. This a half is this a half. This -2 is this -2. 2 times -3 is -6. See it right here, so. 2 times -2 is -4. See it right here, so. This one is this one. Good. -2 minus 6 is -8. -8 minus 4 is -12. -12 plus 1 is -11. And 2 times 11 is going to be 11 over 2. Answer. Boom. Tell me that difficult.
Difficult, sir.
All right. Topic is done.
Sir, enough things
No.
remember. Enough things remember this. Yeah.
Well, guess what? Guess what? It's no hard, man.
You need rum, sir. You need rum.
You see,
Sir.
from last semester, me hear you and Kenneth talk about rum, you know. And I know we
Sir,
listen
must
to
say
rum.
who case in sir.
Who case?
You forget, sir?
Sir, you want me to
Anybody-
attack the case, sir?
Start of the course.
Anybody who gets an A in my course needs to buy me a case of rum. Did anybody get an A?
Minus. Close enough.
I don't care. A minus, A plus. Anybody got an A? Anybody got an A supposed to buy me a case of rum?
Sir, you want me a case, sir? Everybody change them out now.
Sir, watch it, sir. Watch it,
Sir.
sir. Whoever
And
get
guess
the
what
A
now?
supposed to give
Sir,
you
I
the
feel
case
that
of rum.
case
Whoever get
for
the
power,
B,
sir.
you're supposed to give them the case of rum.
Whatever. Well,
Mr.
well,
Mark.
be careful. Yes, sir.
Yeah, change the mode power, you know, sir. Yeah, you can get to say if you pass, no, sir. If you see a police school compound, you ask if you run money.
Listen to me, man. You know, don't listen well alone. That's not what I taught you, right? You must listen. Go back and play the recording.
Sir,
You know, after
you remember well, sir. You remember well.
Ain't
Get it?
no
I like me, I tell.
No, you can't ask any of them questions. Because you can't tell liar. You can't tell liar. But I forgot to ask Kahim. Kahim don't answer. All right, let's go. So,
Lecarno
guys,
and Tikel, they as witness to, sir.
no, man. Lecarno? No, Lecarno good, you, man. Lecarno going to tell you the truth. All right. Put it this way now, guys. The topic is really not difficult. Trapezoid, it's finished, you know. I'm going to send you this. I'm going to send Lecarno this example, this stuff tonight. I'm going to look for the other stuff that we did last week and set up, but I'm going to send him this one tonight so he can look back at it. Trapezoidal is really not difficult. If you follow what I gave you as that example with your hand, you can never forget trapezoidal. Sometimes a question, and I will end it right here. Sometimes a question will say to you, using the oh god, come on now, brain freeze. Using the trapezoids or using the ordinals. So sometimes a question will tell you that has X number of ordinals or X numbers of trapezoids. So you no need to remember. You no need to remember. So this question says, use trapezoidal rule to estimate this ugly function with 6 ordinals. How many trapezoids it has?
Sir, 5.
Very good. I know, you know why we need 5? Because when you calculate the width, it's going to be the upper limit minus the lower limit divided by 5. So it's going to be 3 minus 1 over 5. See it here? Over this 5. So you can't say because it has 6 ordinals, we're going to divide it by 6. And this is where my students of Calculus 2 going to the exam and make a mess. And I get really upset when I'm marking this stuff because it says to me that when I'm teaching, they're not following me. Let me say this one more time. I get upset because I go through the example of using the hand to do the stuff, to explain in class. And I say sometimes a question tell you say it has X number of trapezoids, like the first example that we just did. But this year example 2 that I'm going to be giving you, says with 6 ordinals. But because they don't listen, them go and say V minus Vx, V of X is going to be B minus A over 2. Them get the B minus A, no? The 3 minus 1, them get that right. But them divide this by 6 instead of dividing it by 5 because it has 6 ordinals. So the number of trapezoids is supposed to be 1 less, and you're dividing this by the number of trapezoids. So remember that the ordinals is 1 more than the trapezoids. You're not going to need this now. Now when you reach here, so you're going to have the ordinals. And this tells us the width. So if the ordinal is 2/5, it means that I'm going to start with 1. Then 1 plus 2/5 is going to be 7/5, plus another 2/5 is going to be 9/5, plus another 2/5 is going to be 11/5, plus another 2/5 is 13/5, plus another 2/5 is going to be the whole number 3. Let us check to see if we have 6. 1, 1, 2, 3, 4, 5, 6. And if I use my commas as my trapezoids, 1 comma, 2 comma, 3 commas, 4 commas, 5 commas. So all you have to do to remember this topic is the number of trapezoids, the number of ordinals. The number of trapezoids, the number of ordinals. Ordinals is 1 more than the number of trapezoids. Ordinals, 1 more than the number of trapezoids. Trapezoids, ordinals. Ordinals, trapezoids. V of X is B minus A divided by N, the number of trapezoids. Be careful, the question sometimes may say it has N equals 3 or 3 trapezoids. Or sometimes it may say it has 3 ordinals. If it has 3 ordinals, that means it has only 2 trapezoids. Big up on yourself. Have a good one.
Bless up, sir.
All right, that's a
Easy.
good one, sir.
Have a good evening, sir.
Yes, sir. Respect. Remember your room next class.
All right then, cool.
So I need to catch up. So
Yeah, man, we'll do for you,
a lot
Papi.
of videos. All right, thank
Cool.
you.
Mhm.